Have you ever looked up at the stars, watched the sun trace its slow, majestic path across the sky? It feels so calm, so predictable. But all of that movement, that gentle rhythm of day and night, is down to something truly extraordinary. Our planet, this beautiful blue marble we call home, is spinning. It's hurtling through space at an immense speed, yet it rotates on its axis with a grace that cradles life itself. But what if it didn't? What if in a single silent moment, the Earth just stopped? It's a question that sounds like it belongs in science fiction, a wild thought experiment. But by asking it, we can begin to understand the profound and delicate forces that shape our existence. It's one of the most brilliant ways to appreciate the world we have. This isn't just a simple query. It's a key that unlocks the very physics of our world. The answer isn't a single simple event. It's a cascade, a domino effect of catastrophic proportions. The consequences would ripple through every aspect of our planet, from the air we breathe to the ground beneath our feet. Before we dive into the chaos, let's appreciate the calm. The Earth's rotation is a fundamental part of our world, yet it is so smooth we don't even notice it. Our planet completes one full turn on its axis every 23 hours, 56 minutes, and 4 seconds. This is what we call a day. At the equator, the surface of the Earth is moving at a staggering speed of about 1,670 kilometers per hour, or around 460 meters per second. That's faster than the speed of sound. Even here in the United Kingdom, we're traveling at a breezy 1,000 kilometers per hour. Now, let's return to that terrifying moment. The Earth stops spinning, instantly. What is the very first thing that happens? The solid planet beneath your feet comes to a dead stop. But you don't. And neither does anything else that isn't fused to the planet's bedrock. This is because of a fundamental law of physics, inertia. Let's delve deeper into this concept of momentum. Momentum is simply mass in motion. Everything on the planet has it, thanks to the Earth's spin. When the Earth stops, that momentum doesn't just disappear. The law of conservation of momentum states that it must be transferred. In this case, it's transferred into pure destructive kinetic energy. Every single object would continue its eastward journey. While the land is being scoured into oblivion, something even more dramatic would be happening to the oceans. Like just as with the atmosphere, the Earth's vast bodies of water possess enormous momentum, and when the solid Earth stops, the water does not. The oceans would continue to surge eastwards, creating a tsunami of truly planetary scale. It would surge eastwards, crashing over Europe and Africa with unimaginable force. The change in the world's geography would be driven by a fundamental shift in the forces that shape our planet. As we've mentioned, the Earth is an oblate spheroid. It bulges at the equator. This bulge is a direct result of the centrifugal force created by its spin, the same force that tries to throw you outwards on a merry-go-round. This force effectively counteracts gravity, ever so slightly. This means that gravity is a little bit weaker at the equator than it is at the poles. Let's assume, against all odds, that the planet has settled. The winds have died down, the oceans have migrated, and the initial cataclysm is over. What would life be like on this new stationary Earth? The most immediate and stark change would be the cycle of day and night. What would become of the biosphere? The initial catastrophe would have caused an extinction event so total, it would make the end of the dinosaurs look trivial. But let's imagine some simple life forms survived, perhaps deep in the Earth's crust, or in the deepest parts of the newly formed polar oceans. Could life ever make a comeback? So our thought experiment has taken us on a journey of unimaginable destruction. We've seen how a single change, the cessation of the Earth's spin, would lead to a cascade of catastrophes. But it reveals a beautiful truth, just how profoundly important the Earth's rotation is. The gentle 24-hour cycle of day and night is far more than just a convenience. It is the metronome that regulates our climate. The next time you watch a sunrise, remember that you are standing on the surface of a giant spinning sphere. You are a passenger in a grand cosmic dance, a dance that has been unfolding for billions of years. It is this motion, this elegant and reliable spin, that makes our world a living, breathing paradise in the vast, silent emptiness of space. And that is a truly wonderful thing to understand.